Hey guys, my name is Liam Moskal. Today I'll be talking about airbags, so super interesting, but more importantly, I'll be talking about the Takata airbag recall, also known as one of the largest or the largest automotive recall in history. And for my ethics project, I'll be focusing mostly on the profit versus protection of the people. Alright, so a little overview on what I'll be talking about today. I'll be going over the background, kind of what Takata is, who they are, where they're from, kind of what they do. And then I'll go into a little bit about how airbags work. I'll be going into the basics before I get into like the nitty-gritty of my presentation. Then I'll go over some of the positives and negatives that I've found that happened throughout this ethics topic, some of the conflicts that I've found, as well as my personal opinion throughout doing my research and presentation. Alright, so some of the background on who Takata is and what they do. So they're a company that was founded in 1933 in Hakone, Japan. So that's like dead center of Japan, right in between all their major cities. And they originally produced parachutes for Imperial Japan during World War II. And then once that kind of died off, once they got bored of that, then they switched to airbags in the mid-1980s. So a little history on and foresight on why the recall happened is that they switched their chemical compound that was in airbags to ammonium nitrate, which greatly decreased the cost of making airbags by a couple dollars per unit. And then the defective airbags started exploding. That's a little hint on my whole ethics topic. And then many people in the company, including the engineers as well as the senior executives, knew about the defects, but due to the increase of money that they were making, they kind of pushed it to the side, thought it would be okay. And as I said earlier, this is the largest known automotive recall to date. Alright, so a little bit on how airbags work. So you got sensors all around the car, as you can see here, that detects a crash. And it basically, through via wires, it sends signals to the airbag system, as you can see on the top one. It sends it to the inflator, which the inflator basically sets off a chemical reaction, which now we use nitrogen gas, which is much more safer than ammonium nitrate. And it basically sets off the mini explosion, inflating the bag in a very short amount of time. It's about sub 1 second. And then obviously it blows up to cushion the driver, saving anyone from a potential fatal crash. Now the problem that Takata had here is that, as you can see up here, whenever the ammonium nitrate was subject to excessive heat or humidity, the ammonium nitrate got really riled up, simply put, and whenever the sensors did tell the ammonium nitrate to explode, it exploded way too aggressively, sending little pieces of metal, otherwise known as shrapnel, throughout the car, piercing headrests and the roof, and ultimately people as well that was inside. So that was really like the big problem with their ammonium nitrate. And then the problem is that they forced a more cost-effective airbag to stay competitive with other airbag companies, leading to unsafe design choices, and I'll talk a little bit more about that in a minute. So some of the positives that came out of this event was that safety regulators became much better and much more strict. So I'll talk about the specific safety regulator that was involved in the Takata airbags in the next slide, but they became much more strict. Back in the 80s and the 90s and early 2000s, when they were making airbags, they were a little bit more lenient, leading to problems like this, as well as it wasn't fully their fault, but the engineers and senior executives knew that there were some problems and they kind of forged some data. And then engineering ethics as well. It's a worldwide example of how important safety is for us engineers to really design stuff that is going to keep people safe. Like, that's our ultimate goal. And it really opened people's eyes to engineering ethics. And then quality control as well. So better auditing came of this. It basically made everything, as I said earlier, more strict. But now they do much better tests. You can go online, find crash videos of current modern airbags. Then some of the negatives. So I'll start off by saying that there are over 25 deaths and 400 injuries that were confirmed to be due to the Takata airbag malfunction and recall, which ultimately led them to file bankruptcy. They had over 100 million airbags that were forced to be recalled due to their whole problem, which then led to over $1 billion worth of lawsuits. About $850 million of these lawsuits went to criminal charges against the engineers that designed it, against the regulators that accepted it and approved it, and then as well as the senior executives that were overseeing the project. Public trust as well took a very big hit. Regulators such as the National Highway Traffic Safety Administration, or the NHTSA, they took a big hit, and public trust really just plummeted because they were the main regulators that were overlooking the Takata airbag situation. And then as well as that, car manufacturers such as BMW and Toyota also took a massive hit. So if you see on this graph right here, it's a little hard to see for you guys, but this is 2012 to 2015, and this is how many cars were recalled with Takata airbags and how many were manufactured from 2012 to 2015. As you can see, due to their cheap prices and what seemed like a really good plan, their airbags skyrocketed in sale, which ultimately led to the lawsuits and the deaths and the injuries. So BMW and Toyota were publicly blamed because people thought that they were the ones that were manufacturing them when they weren't. They were just the customers of the airbags. And then obviously the biggest negative of this whole thing is the engineering failure that led to the recall. The lies that everything was fine from the engineers and the senior executives. So a little bit about industry change here. Public awareness, as I kind of touched on last slide, really increased. People realized how important it is that engineers are so pinpoint with what they're doing that, I mean, something as little as like an airbag that you might not think about every day is so important. And if something happens, I mean, something that should be saving lives can take them. Industry transparency as well has also gotten much better. So this kind of goes with the defects and other recalls of cars. We talked about in the ethics class that Volkswagen had a recent recall due to their technological system. And those are all free of cost because it is the engineers that are the ones that are manufacturing cars. And then improved technology, as I talked about earlier, that they changed the explosion, you could say, in the airbags to a safer chemical compound. So that is also very good that they improved the technology for airbags. And ethics training has also become much more prominent in the engineering field. After this, so many news articles, so many people, or this got so much publicity that they had to make a change. Now, my opinion on this whole thing is that the money that they were racking in, they were making hundreds of millions, if not billions of dollars. They were saving a couple bucks per airbag, and they made hundreds of millions over like the 10, 15 years that they were making them. So the money looked really good, but the lives that were lost were just not worth it in my opinion. And I think everyone else can agree with that. And then this also leads to concern that there are engineers out there that are doing it for the money and not so much for the betterment of people and making life easier, and that people will be choosing money over ethics. And then as well, a little side note, it's hard to not feel sympathy whenever I'm doing my research and presenting a topic that's heavy-hearted like this. So some of my conclusions that I want you guys to stick with is that we are designing things to save lives and make life easier, not trying to take them or have the possibility to. That's why we gotta be so thorough whenever we're doing ethics. And then cost cutting, as you can see here, can be very severe. It can lead to lives being lost. And then I think the most important thing here is that ethics should always be put before profit. And my closing statement is that when corners are cut, lives can be lost, and that's just something that no engineer, I mean, me, you guys, ever wants. So, any questions? All right, thank you guys.